In a previous video, I introduced the concept of an extremely useful market research technique called conjoint analysis. Conjoint analysis is also called trade-off analysis because survey takers are literally making trade-offs as they select between products that are presented to them. In this video, we'll be diving a bit deeper into the mechanics of conjoint analysis. We'll talk about the blueprint of the choice task called experimental design. We'll talk about prohibitions and why you should be extremely careful with them. We'll talk about the none option in the choice task. And we'll mention something called dominated alternatives. If you haven't seen the first video, I highly recommend that you start there. Otherwise, a lot of what we talk about will sound foreign to you. If you have seen the first video, then you should be ready to jump into some deep waters with me as you learn the ins and outs of this extremely useful technique. As I mentioned in the first video, the first part of the conjoint analysis is a survey-based exercise called the choice task, or a series of choice tasks called the choice exercise. In the choice exercise, survey takers are shown products and product descriptions side by side. They evaluate them and select the one they're most likely to actually purchase. These products are actually a list of product attributes and their values. In this example, a survey taker may be evaluating credit cards. As you see here, they're evaluating 3 cards side by side. They're given information on what brand it is, what type of card it is, MasterCard, Visa, or American Express, what the annual percentage rate is for each card, and what type of reward each card offers. Once the selection is made, a new set of credit cards are shown with a very different combination of benefits and attribute values. The purpose of the choice task is to see and measure how customers choose in this category. What attributes are important when making selections and what are not. People that are not very familiar with conjoint analysis tend to confuse the choice exercise with a product concept test, and they insist that one of the options be their product. This is a serious error because survey takers' choices are used to build a statistical model. And to build a robust model, survey takers need to have seen and evaluated as many possible combinations of product attribute levels as possible. And there are a lot of combinations. If we assume that in our credit card example there are 4 possible brands, there are 3 possible card types, and there are 5 possible APR values, and there are 5 possible rewards, we can arrange these attribute levels to create 300 different products. But that's not all. If we consider that survey takers are going to choose one product over another on each choice task, we could create 27 million different choice tasks, each showing a different set of products side by side. So how do we decide what combination of attribute levels, in other words, products, to show the survey takers? The answer to that is in the experimental design. The experimental design is the blueprint of the choice task. The experimental design dictates what is shown to survey takers on each screen. This is an example of an experimental design. It has information on what version of the design it is. It has the choice task number, the concept or the option survey takers are to choose from, and the information on the various attributes: brand name, credit card, type, APR, and rewards. Okay, but how does this spreadsheet with all these numbers determine what is shown in the survey? In order to make sense of it, let's first look at what is called the attribute level grid. For our credit card example, here's the attribute level grid, which shows the attributes we use in this study as the rows and their levels as the columns. For example, the first attribute is brand, and we can see that on this grid, the brand in the first position is Citi. The brand in the second position is Chase. Third position is Bank of America. Fourth position is Wells Fargo, and fifth position is American Express. These are the first, second, third, fourth, and fifth levels of the attribute called brand. The rest of the attributes, card type, APR, and rewards, are organized the same way. In the experimental design, each row corresponds to a product concept that is shown to survey takers. Because in our credit card example, we show 3 products on a screen, 3 rows together represent one choice task. So let's take a look at the first 3 rows. The first item says this is version 1 of the design. Because we're building a robust statistical model from the survey takers' many choices, it is common to have lots of different versions of the experimental design and randomly assign those versions to survey takers. This ensures that survey takers will have seen as many possible combinations of the attribute levels as possible for the model to be able to estimate the effect of each level on customer preference. The next column is task or choice task. Typically, each respondent sees somewhere between 8 to 12 choice tasks. So here you can see which choice task it is referring to. Then concept. In our example, we show 3 products side by side. So these rows reference the first, the second, and the third product concept to be shown on a choice task. If we had shown 4 products side by side, we would see 4 rows for the 4 product concept. Next, brand is the first attribute. And on the first row, the design says, show the 4th brand on the choice task. The attribute levels grid tells me that the 4th level of brand was Wells Fargo. And as you can see on the survey choice task, correctly, on the first choice task for the first product, the brand is Wells Fargo. The same way, it tells me to show the first card type, which is MasterCard, show the second level for APR, which is 19.99%, and the 4th level, the attribute rewards, which is travel points. This is how the experimental design references what gets shown in the survey to survey takers. The design plays a major role in whether the conjoint analysis is able to estimate robust measurements. It's important that all the attributes and their levels are shown roughly an equal amount of times to respondents. It's called a balanced design. Imagine, for example, if one of the brands, say Wells Fargo, is hardly ever shown during the exercise. The model would struggle to estimate the impact of Wells Fargo on customer preferences if it's not shown enough. It's also important to create what is called overlap in the design. Overlap means that a level for an attribute is repeated in the choice task. For example, here you see the brand Citi in 2 products. When you have overlap, it helps the model learn more. Imagine if there's a respondent that always chooses a product that has a certain brand in it. For example, Citi. The model would learn that this survey taker really likes Citi and no matter what, always chooses it. When there's an overlap, it forces the survey taker to reveal more detail on their preferences. If you really like the brand Citi, how do you choose when there are 2 Citi cards? What else, apart from Citi, is a deciding factor? So allowing overlap is very useful in a good design. So what happens if these somewhat random combinations of attribute levels happen to create a product that makes no sense? For example, if your products are cars and your design creates a Tesla that runs with a gasoline engine, obviously there's no such thing as a gas-powered Tesla. In that case, you can set up prohibitions in the design. Prohibitions, as the name suggests, prohibit an attribute level to show up when another attribute level is present. For example, when the brand Tesla is present, make sure that the engine type gasoline is never shown. Or in our credit card example, when the brand American Express is shown, make sure that the card type is never Visa or MasterCard. While sometimes it is necessary to set up prohibitions in the design, I need to stop and give you a big warning here. Prohibitions make your model's estimation worse. The more prohibitions you set up, the worse and worse your model will be. I cannot emphasize enough to only set up prohibitions when they're absolutely necessary. Remember, the choice task is not a product concept test. It's only an exercise to train a statistical model based on preferences and selections of survey takers. So it is okay to show products with attribute levels that may not exist in the market today. It's okay to show a brand of cereal with a flavor that is not in the stores today. Clients often insist to set up prohibitions because certain attributes don't exist with other attributes in the market today. That's a big mistake, as prohibitions tend to harm the model. Again, only consider adding prohibitions when they are absolutely unavoidable, and be okay with showing products in the choice task that don't actually exist in reality. Let's talk about the none option in the survey. In the choice task, we're showing a couple of products to survey takers and ask them, which of these products would you be most interested in buying? But what if the survey taker finds none of them appealing? After all, we don't want to force them to pick something they don't like. For that purpose, a choice task should always include a none option. There are two main ways a none option can be included. One way is to include it as one of the options to pick. So for example, there are 3 credit cards to pick from, but there's an actually 4th option which says, I would pick none of these credit cards. This way, we give the survey taker an opt-out, a way to say that the options shown are not preferred by me. There's a disadvantage to this approach, namely that the model learns nothing about the survey taker's preferences when they pick none. Imagine the extreme example where a survey taker selects none of these across all the choice tasks. The model will have no information from that survey taker on how they like brand, APR, rewards, or anything. Because of that, there's another way to deal with this situation, which is called dual response none. In the dual response none, we ask survey takers to pick one of the options, but then in a quick follow-up question, we ask whether they would truly actually purchase the item they selected, yes or no. The benefit of the dual response none is that the model can still learn about survey takers' preferences, and will use the dual response none to adjust the survey takers' utilities based on the answers they gave to the follow-up question. My recommendation is to include a dual response none in a conjoint exercise whenever possible, simply because it will create a smarter model. The final concept I'd like to discuss in this video is the concept of a dominated alternative. Normally, in a choice task, we show a combination of attribute levels side by side, and we ask survey takers to evaluate these products that they see side by side and eventually pick the one that they like the most. When survey takers evaluate the products, they are making trade-offs in their minds. They may like the brand of one product but dislike the rewards. They may like the APR in another product but dislike the brand. But what happens if one of the alternatives is an absolute no-brainer? On every attribute, we show the most desirable level. Imagine a Porsche with $25,000 with a 10-year warranty. That would be called a dominated alternative. Unless the survey taker is not paying attention, that option will be selected by everyone. There's a myth among market researchers that dominated alternatives are damaging to the model, and the model does not learn when dominated alternatives are present. The reality is different. First, in a well-designed experiment, dominated alternatives are rare. Maybe 3 out of 100 choice tasks contain dominated alternatives. But more importantly, it has been scientifically proven that dominated alternatives cause no harm to the model. There's not a need to spend the extra time and effort finding dominated alternatives in the experimental design and altering them. It would be a complete waste of your time, so leave them in the design and move on with more important things. I hope you enjoyed this video as we dove a bit deeper into conjoint analysis. Coming up in our next video, we will go even deeper as we discuss some of the model estimation methods, particularly something mysterious called the hierarchical Bayesian estimation. In addition, we'll discuss some of the common issues that come up with conjoint analysis, such as the red bus, blue bus problem. See you in the next video.